by Malware on your phone now. Computer is a dinosaur, right?
Getting there.
Getting there? Okay. So please welcome Jeff Holden.
Thank you. Can everyone hear me? We're good? All right, so I'm looking at mobile malware today, like you said. Mobile space has absolutely exploded within the past 10 years or so. You know, back before 1992, there was these things called mobile phones that actually just did one thing. They just, made phone calls. Can you imagine that nowadays? So we saw the start of smartphones back in 1992. The IBM Simon came out. It was the first kind of smartphone. It's pretty, pathetic in today's standard, really. It included, address book, world clock, calculator, notepad, 2 games on there. You could even send and receive faxes, but that was really the start of it. So we're going from 1992 to today, 2011, which is not really in the scheme of things that long time. The next iteration came in 1996 with Nokia's 9000 series, which combined the PDA and a wireless phone. That was more of a more modern device. As you can see, the 9000 series was one of the first phones to use color screens and Wi-Fi, so it really brought it into more the 2000s. And the Nokia 9210 communicator was the first to use Symbian OS, which is an important milestone, at least for malware authors' perspective, because before Symbian, each cell phone manufacturers kind of had their own custom OS. There wasn't really one standard operating system, so if you were going to do malware, you had to write it for every single different platform. Now with Symbian OS, you had a standard platform that more manufacturers were using. So Nokia was using it, Ericsson, other smaller handset manufacturers were all using the Symbian OS. So in 1997, Ericsson released the GS88, which was the first phone to actually use the term smartphone in the title. So that's kind of where that term smartphone came from. So it's after that, we had a kind of 2000 to 2002 really saw the explosion of the market, mobile smartphone marketplaces. Windows Mobile and BlackBerry came to market. It just exploded at that point. So now you also had standard platforms, you had major manufacturers behind it, you had the corporations now embracing it with the BlackBerry platform, so that all the C-level people can get all their email on this little device that they carry around. They could also download applications and do other things with it too. And so from 2000 after that, the field kind of stagnated from 2002 on. You didn't really see any real innovations, until you saw in 2007 the iPhone got released. So that was the major pushing point to that pushed everyone forward to what the phone could do. And if you remember 2007, the iPhone was revolutionary user interface. It blew anything out of the water. You had but it was pretty limited. If you remember, when it first was launched, it didn't have GPS, it didn't have apps. It was just Wi-Fi, and you could browse the web, look at your calendar, email, that kind of stuff. And at first, Steve Jobs did not want anyone to put on applications on the phone. He thought it was too big of a security risk. He didn't want people to be in charge of their own user interface, all that kind of stuff. And he thought that mobile platform was fine. You could make web apps. But you're pretty limited with web apps. You don't have any local storage. You can't do a lot of things. You don't have direct access to a lot of the things the phone has, such as the GPS data, all that kind of stuff. So they finally relented. And of course, we all know what happened today. It's huge. It's the #1 used smartphone, anyways, out there today. A little bit later, 2008, Android was released by Google. It is #2, right behind the iPhone. It is now actually outselling the iPhone in new sales. Look at the slide here. You're going to look at the market share. So this is the mobile operating system market share of new sales. So this isn't the total, that's actually being used. This is how many are selling. So if you look at back in 2007, 63.5% of the phones that were sold in 2007, Q1, was Symbian operating system, which was huge. I mean, no one could market. Down here, you have Windows Mobile at like 12%. So this is the number one reason we see that mobile malware, by far, was Symbian, and it still continues the total number of mobile malware out there. Symbian has the most malware out there. So if you look back here in 2000, here's where the iPhone was released. You get a slower adoption, but by the time you hit here, Symbian has this nosedive way down here. You see Android with this very slow start, and it just takes off like nothing as the operating system improves. Android had a pretty slow start. Its operating system wasn't that user-friendly and usable until about 2 years ago. They've continued to improve it incrementally. It's gotten a lot more of a competitor. So by 2014, Gartner predicts that Android will actually be the most popular platform. Will actually surpass not only sales but usage of of Apple. And they also predict that by 2013, smartphones will outsell PCs. So you're looking at the consumerization of them. And I don't know or not, if I didn't look at the exact statistics, but if that includes tablets. That's definitely the case when you see tablets today and combined with the smartphones. More and more people just don't need a computer. I mean, what do? They browse the web, they talk to their family, they message, instant message. There's no real need for a lot of people to have a big computer and use it, especially older generation, younger generation. Unless you need the power behind a computer, people just aren't bothering you. So let's look at a little bit of the history of mobile malware. So back in 2004, the only game in town pretty much was Symbian because it was, like I said, standardized across multiple handset manufacturers. So the Kabir worm appears. Now, the Kabir worm was basically a non-malicious proof of concept written by a group called 29A. So this was a group of malware authors. They just basically, their hobby was writing malware. So they sent out this malware to the AV companies and said, here, see what we did. Isn't this cool? What it did was actually just spread via Bluetooth. So it would, you would get on your phone, and then your phone would just start sending it out, file transfer, peer-to-peer, to anyone within range to you. It didn't really do anything except spread. So then we go down to also 2004, QDial was released, and this is the start of premium rate SMS Trojans. So does everyone know what an SMS Trojan is? Anyone? No?
I could guess.
Go ahead.
Basically, it sends spam to your friends.
No, it actually does premium rate SMS messages. You know those little 5-digit messages? You can donate money to the Red Cross, you can buy ringtones, or you can get sports scores or something like that, subscriptions. That's what premium rate SMS messages are. And those have been the number one basically driving rate of the mobile Trojans thus far, because that's, whenever you bring money into it, that's when you start seeing motivated malware authors. So you get all the organized crime like the Russian business network or some of the other high-tech criminals now involved. They're spending their time and resources now to do it because it's profitable for them. So you see the first rise of the SMS Trojan, and that's one of many. That's at this point still the number one type of malware you'll see out there for the phones. In 2004, Skulls is discovered. What this basically does is it was originally non-malicious. All it did was change all your icons to skull and crossbones. So at first it was just downloaded on peer-to-peer networks. It claimed to be something else. And then later on, they actually modified it and use the Caber to propagate. So what they basically did was combine their skulls with Caber. Now you have something that can propagate across Bluetooth and actually does something more than just propagate. It actually propagates and changes all your icons. Still not terribly, destructive. You just had to reset your phone and go on your way. So it didn't download any personal information or anything. So then in 2005, PV Stiller shows up, and what that did was it combined also the Caber propagation with Bluetooth, and what it did was steal your phone book. So if you send it, if you got it through Bluetooth, it would now take your phone book and send it to anyone within range that wanted to copy it down. So this would be useful in, for instance, corporate espionage. You get all sorts of contact information, or even a lot of people will store username and passwords within their address books. So that was the motivation for PV Stealer. In 2005 was the first message we saw spread by MMS. They used a flaw in Sybian's SMS system to actually spread virus through SMS. You no longer had to be within radius of someone anymore. Now it could be sent off to everyone in the world, basically, propagated. And of course, malware for other platforms such as Windows CE, BlackBerry, also showed up, but they weren't nearly as dominant, like I said, as the Sybians, just because the market share was not there. So if you're looking at financial motivation, just like we're seeing in the PC versus Mac versus Linux race today, you don't really see much malware for Linux and OS X. Why? Not because it's more secure, just the market share is not there. If you're a criminal organization, you run it like a business. You look at your market share and go, okay, 93% of the PCs today are running Microsoft Windows. Let's focus our attention there. We're going to get the biggest return. So for that reason also, the malware was for a long time only focused on the Symbian platform. So why do we care about mobile malware? No one really, a lot of people just, I got this thing in my pocket, I can do whatever I want with it. It's more intimate than a computer is. You use it all the time. So that's one of the main reasons you should be carrying mobile malware. Look at all the private information that you store on your phone. When you have all the numbers of everyone you know. So if someone wanted to, for instance, socially engineer your friends, they'd have all this information that they could use. They could call your mom, they could call your girlfriend, cousins, whatever. Everyone. They have all your emails, so any private information you're sending back and forth in your email now can be seen. So maybe there's blackmailable material on there. Texts, pictures, all of that information could be stolen potentially if your phone was infected with malware. I know pictures, for instance, there's been a lot of, the Scarlett Johansson picture came out. There's been a lot of celebrities that had pictures stolen off of their phones by people with mobile malware and hacking. So that's a big thing that you want to look out for. But also, just for spying purposes. What if someone is able to install some malware on your system, and now what does your phone have on it? It has GPS, it has a camera. It can then send back information to whoever installed it on where you are. It can take pictures, it can take video. There's a lot of things, that you would probably not want people knowing about. Maybe not for privacy's sake, but I mean, your phone's everywhere. I mean, people take it in the bathroom, they take it in the shower. You don't want people to be able to access your camera at any time. There's people that do lots of mobile banking. There's mobile banking apps on there, so potentially they could get your username and password and be able to steal money from you. And another thing is there's a big lack of antivirus on the mobile platform. For one reason is just the lack of resources on a mobile device. You don't have the CPU power, you don't have the battery power to have something running in the background all the time like on the PC side that you do. And on, at least for Apple's side, they're not going to let you have that low-level access to their device. They just don't want you, that's part of their security model, is not to let people have that low-level device in the first place. So there are, you know, an AV out there for Android and Symbian and some other platforms. It just, you know, not a whole lot that you see. You're going to see your reduction in battery life and your resources. So let's bring it down, bring it back to the present now. Let's look at some modern malware. So iOS, Apple's operating system used for all the iPhones and iPads out there. It's a, and iPod touches, I should also say. Apple iOS is a closed ecosystem. Any application that you want must be downloaded through the official Apple App Store. So all apps have to be reviewed and approved by Apple to get on there. You know, they have a set of guidelines and things you're allowed and not allowed to do. You know, you can only use their official API to you know, get things on the phone. If you want to have access to the GPS, you actually have to ask. On most apps, you'll see that pop up. You know, this app wants to use location server. Are you sure you want to let it? But beyond that, that's about all you're going to see Apple ask you is, you want to let this application have access to where you are. You're not going to see it say, oh, do you want to allow this application to be able to send SMS? All that kind of stuff you'll see in the Android world. All the applications are digitally signed, and Apple won't allow non-signed code to run on their platform. So if you take an app and somehow able to take it out of the App Store, change it around, and put it back on the handset, it wouldn't run anyways because it's going to check that signature and it's not going to match it after it's been changed. And they've had a relatively clean record. The operating system has advanced features that you'll see on the desktop systems, such as ASLR, which is address space layout randomization. What this basically does is take the chunks of code that the operating system uses, and it randomly puts it in memory. Before this was around, you'd basically have all your memory, your libraries in memory would be static. So you'd have it up here, you know, be here, and always be in the same exact places. So what that would allow you to do is if you had a bad program that didn't check parameters, that would basically allow you to do a buffer overflow is what that's called. You know, maybe a little more technical than this talk is, but if you have any CS students out there, you probably understand. So basically, without address space randomization, if you had a buffer overflow, you know exactly how much padding you needed to get in memory to get to the spot where you could overwrite protected system information and be able to take over the system. Also, depth data execution prevention basically would not let you run stuff on a stack that was supposed to be data. So it would differentiate between your data and your execution information and would allow you to run things that weren't supposed to be run, basically, in a simple form. So let's go on here. So the only real in the wild malware that has affected iOS so far was a worm that only affected jailbroken devices that didn't change the default SSH passwords. I'm going to let a little bit more into jailbreaking in another slide coming up here. So basically, you had to do something, break the device in the first place to be able to get this worm. And you didn't follow the security steps afterwards by, you know, best practices of changing your password, which is what got these people. It wasn't really an Apple. Well, originally it was an Apple flaw that allowed the people to jailbreak it, but after that, it wasn't Apple's fault, really, that this got on the phones. Flaws that are found are quickly patched and updates are released within the iOS. So there's been, you know, a bunch of, or well, I shouldn't say a bunch, but there's been flaws found in the operating system. Charlie Miller, if anyone's heard that name, that guy's legendary in the Apple hacking space. He's won pwn to own for the Apple operating system, breaking Safari multiple times. He was, I believe, the first one that actually was jailbroke the Apple iPhone by finding vulnerability in the mobile Safari browser, which allowed people to sideload, put other applications on the phone other than through the official Apple Store. So the application review process has been pretty effective until there's been no malware found in the official Apple Store until yesterday, actually. And that also was Charlie Miller, who showed a proof of concept. It wasn't a malicious app, it was just a proof of concept. And let me actually show you a demo of his. This is a video of him explaining a little bit on what he was able to do.
Hey, I'm Charlie Miller. I'm here to talk to you about a flaw I found in the way iPhone handles code signing. So, code signing is important because that's the way that iPhone protects you from malware. So, all the apps that you have on your phone have to go through the App Store. And at the App Store, they have a chance to check it, make sure it doesn't do anything bad. And then when the apps you download from there you can trust are safe because Apple's looked at them. And they can't change what they do or do anything different. The flaw I found allows apps that are in the App Store to download new code and run it even if it's not signed and even if it hasn't been checked by Apple. So, so you can imagine downloading a nice app like Angry Birds, but instead of just being Angry Birds, it actually can download and do anything at once, and Apple would have no idea that happened. So let's take a look and see how this works. So the first thing we have to do is download the app from the App Store. Now this app is a stock market app that I wrote. The first thing it does is it checks in with an attacker server to see if there's any code it should download and run. So here we installed it, and let's run it. So this first time we run it, it checks in, but there's nothing for it to download and install. So it runs just like it was supposed to, and this is exactly the experience that the people at the Apple Store got when they were reviewing it. So it doesn't do anything weird or funny. It just shows you the stocks. You can see here that it was checking in for the library to download and run, but there was none. So let's try it again. But this time we're going to set some code there for it to download and run. Remember, this is code that is unsigned. Apple's never had a chance to review it, and yet it's going to run on this iPhone. So let's download and install it again. I only check for the payload when you first run it for the very first time. So this time we run it, and as you can see, something different happens than last time. So again, this is code that was not reviewed, and it could have done anything. And so it gets around the processes built into the App Store to stop this.
So classic Rickroll.
Here's the payload I have that the app can download and run. And this one's a little worse, and something Apple didn't have a chance to.
I'll stop it there. But he goes on to show that he can now also install an interpreter shell, which basically allows him to take full control over the iPhone or iPad or whatever it was installed on. So Apple, of course, being Apple, instantly did the right thing, and of course banned him from the Apple marketplace for a year. Thanks for finding the flaw. Get the heck out. So basically, what he found was a flaw that worked in iPhone iOS 4.3 and down. And basically, after that, they did some updates that allowed the browser speed to be increased, but it also allowed JavaScript to run at a deeper level, and you found you could run things that Apple didn't approve of. So it would download what JavaScript, and that JavaScript would actually then load code into memory. So that was thus far the only official malware that's been out of the official Apple Store. Okay, so let's look at jailbreaking. So Apple's protections have thus far been very, very effective. You haven't seen anything in the wild malicious as long as you've kept your phone updated with the latest operating system and you haven't jailbroken your phone. So what is jailbreaking? Jailbreaking is basically the few flaws in the operating system that have been found by security researchers have been used to basically gain back control of the device. You know, Apple doesn't allow you to do, you know, you can't put any applications on that you want. You can't access the low-level hardware. You can't, you know, directly access files and GPS, the radio, that kind of stuff. So why would you want to do that? There's lots of reasons people want to do that. For instance, unlocking the phone. Say you bought it on AT&T, but you hate AT&T, you want to use it on T-Mobile. Well, you can use the jailbreak to now go in and update the baseband firmware on the radio and unlock it so now you can use it on any GSM carrier anywhere. So there are reasons you can do it, but definitely you don't want people going in there and doing it that don't know what they're doing, because you're basically now taking a managed, secure phone that, you know, Apple's trying to, you know, put its best practices, for better or worse, on the phone. You know, it's highly restrictive, but it is safe. Most people, I'd say 95% of people aren't going to want or need to jailbreak their phones. There's also added risks now, because now you're using Cydia, which is a third-party app store, to get other applications onto your phone that Apple is not going to officially allow them to do, such as adding, I don't know, I believe, Flash video player, that kind of stuff. But there's also the underside, the dark side of this is piracy. So now that you've jailbroken your phone, you can also pirate apps. But of course, these pirated apps have no review by Apple, so you can now, you know, get to where you're seeing on Android. You could take official apps, you could add extra code in there since it's no longer looking the code signing, and you could put malicious malware out there. Thus far, we haven't really seen any widespread outbreaks of this happening in the wild, but I'm going to predict in the future you're going to see it as it becomes more profitable for malware authors to do so. What could go wrong if you jailbreak your phone? The worst thing you could do is actually wreck your phone. I mean, this is the operating system that you're dealing with here. You're actually going in there at the low level and modifying code on the system. So theoretically, you could brick your phone. You would have voided your warranty by doing this. Apple's not going to fix it, so you just have a $500 paperweight if you did it wrong. So you got to be careful with that. The downsides, now you've jailbroken your phone, you're kind of locked into that operating system. You can't update to the latest iOS anymore, because once you do, you're going to lose that jailbreak. You're going to lose all that software that you installed on your phone from Cydia or whatever other sources that you've installed it from. So there's some major downsides. There are some upsides to it, but I would not recommend, unless you know what you're doing, to do it. So let's look at Android. So Android, on the other hand, is the #1 target of malware authors for smartphones today. There's a few reasons for this. Android is an open platform, and the applications are not reviewed at all by Google. Anyone that has a credit card, and I believe it's $25 for a account to be able to upload things, a developer account. Anyone with $25 on a credit card can get onto the App Store and immediately just put their apps up there with no review process whatsoever by Google. You can also sideload applications. So you don't have to go to the official Google Marketplace to download applications onto Android. There's also ways of going in there and just downloading the files from whatever file share, whatever sketchy file share, peer-to-peer network that you find software on and installing it. There's also third-party app stores that are completely out of control of Google. I know Amazon, I believe, just put up one not too long ago. And there's tons out there in China, and there's pirated app stores all over the place. And Android thus far has lacked some of the security features that Apple actually has. So they don't support ASLR in depth at this point. They're in Ice Cream Sandwich, which is the latest one that they're going to be releasing, I believe, pretty soon. They've included ASLR, but to this point, address-based randomization is not in the phone. So that makes it a lot easier if you find vulnerabilities in the phone to be able to exploit those and basically root the device. Rooting the device is similar to jailbreaking is in the Apple side of things. you're basically going down, the carriers are going to lock this phone down because they don't want you installing, applications. They want to be able to sell you all the things themselves. So people will root the phone and to be able to get complete control of it. So it's a lot easier to root an Android phone than it is to jailbreak the Apple side. Source is available for all the Android operating systems except for Honeycomb, and I don't know if Ice Cream Sandwich was included. I didn't read that far. But basically, you have all the source code, so you can look through all the source code, and that's the great thing about open source, is you can see everything, but the downside is if there's weaknesses in it, anyone that is proficient at finding those can now much easily find the flaws than they can. And for instance, Apple's side, where you're basically doing black box testing, you don't know where the flaws are. You're just fuzzing, you're throwing a bunch of stuff at it and seeing what happens. Now with source code available, it's a lot easier to find those vulnerabilities and exploit them. The other thing is there's many different handset manufacturers. You don't have one platform like Apple does. You have just a handful of phones. You have the 3G, the 3GS, the 4, the 4S. You have literally 5 handsets that you have to do software for. Whereas on the Android side, you have much more. You have x86, you have ARM, you have different processors and different manufacturers making all these phones. So you're going to have a much harder time making applications that are consistent across all of them. You also have different user interfaces for each handset manufacturer. They throw their own on top of Android. The consistency isn't there like it is in Apple. And another problem with Android is carriers are not motivated to upgrade your OS. So even though that there's security updates coming out from Google, why is the carrier going to take the time and money to push out an update to you for your specific phone? Because they actually have to work at it. It's not just a simple process of, oh, here's the update from Google. No, they have to go in and develop they have to port the fix to their particular flavor of the operating system that they've designed for their handset. So a lot of times fixes just are not pushed to the customers, or if it is, it takes them a lot longer to do it than they can, for example, on the Apple side of things. So let's look at some of the problems we've seen in just third-party app stores for Android. In August 2010, the Trojan SMS Android OS fake player is first introduced. So here we see the introduction of the Trojan SMS premium rate messages, just like you saw on the Symbian side of the equation back in 2004. So this was not in the official app store. This was, I believe, in a Chinese app store, and it purported to be a media player, and I believe it's also a porn player that did play media and porno and whatever. But in the background, it was sitting there at $6 a message, sending off SMS messages, and you would end up with a huge bill at the end of this. Your phone company really mad at you. There's also, let's see, November 2010, fake Angry Birds level downloader. So this was a concept, I don't believe it was ever released in the App Store, but this was one of the security researchers that released this proof of concept where it would sit there, you would think it's a level downloader for Angry Birds, you get more levels. So people would download this, and in the background it would actually load 3 different apps without you knowing or giving it permission to download these apps. And it would be able to steal all your contact information. It would be able to send out SMS messages, make phone calls, all that kind of stuff. December 2010, we see Gemini Trojan. The Gemini Trojan was also on Chinese Android app market. Basically, Trojan legit applications. There's a bunch of lists. Jump to President versus Aliens. So they took basically popular applications, and they would go in there and take it, and in the background it would be collecting your information, so you could download the coordinates where you are, the IMEI, which is the International here's International Mobile Equipment Identity. So they would steal that number. What that is basically the identity of your phone. It would also steal the SIM ID from the phone. With that information, they could actually go and reprogram other phones and basically clone your phone. So you download these Trojans, and then later on you get a huge bill because someone has now cloned your phone and is calling all these different countries, running up things on your dime. So that's one of their financial motivations behind the malware. ADRD, Android without the vowels in it, was released in 2011, and that again was another Chinese Trojan. There's kind of a theme running here with a lot of the malware for whatever reason. It installed apps, it downloaded bookmarks, it could send spam, it basically had full control of the phone. My favorite, though, of all time, I think, is April 2011 with the Trojan Walk and Text. This was released on peer-to-peer networking. What Walk and Text is an application that would basically allow you to walk and text. So you'd be texting, and it would have your camera take a picture out in front of you so you could see what's happening in front of you, and you wouldn't run into a pole or a car or whatever. And what this Trojan app would do is you download it, you'd think you're texting your friend, but what would actually be sent out to your friend would be, hey, just downloaded a pirate app off the internet. Walk and text for Android. I'm stupid and cheap. It costs only $1. Don't steal like I did. And at the same time, it would also send off the user's number and information to a third-party server somewhere. So I think that's not really malicious, but kind of funny. It was never really concretely proved whether or not the author of the official app had anything to do with the pirated one or not, Trojan one, but who knows. All right, so let's look at some of the black eyes that Android's taken in the official market store. So early 2010, this user, Droid09, puts out a series of bank phishing applications. So what this would do is purport to be your bank, allowing you to access your bank account information. You'd be able to log on, use your username and password, and be able to manage your bank account information, see your balances, transfer money, all that kind of stuff. What it actually did was just send this user your username and password for your bank app. So they now have control of your bank account and could then send and receive money from you. So pretty nasty. That was the start of the official app store. June 2010, Tap Snake spyware. So what this one was a application that you would play. I don't know if you've seen Tap Snake. You basically, have a snake that gets longer and longer and longer, and you have to not run into yourself. It's been out there for many years. I think it was included on, some of the original Symbian Nokia phones. So they put this application out there. It played just fine, but it never would quit. You'd close it, but it would never actually close. And what it did, in the background, every 15 minutes, would upload your GPS coordinates to a server, a third-party server out on the internet. And another application that could be downloaded called GPS Spy that costs $5, the person that installed this on your phone, so you could go to your girlfriend's phone and install it if you wanted to spy on her. And you buy this other app, and you can sit there and see wherever they've been. They would have no idea because they just thought they had a fun little game that they were playing. That was found in the marketplace. 2011, the Droid Dream Trojan came out. 50 applications that were Trojan. They're basically other popular apps that the person would go in there and run Trojans on. This one was the most advanced Trojan to date on Android, because what it also did, not only did it sit there and download a malicious program, it actually rooted the phone. So it rooted the phone and then installed another application in the background that could then check into a server and download new instructions from it. It stole the IMEI numbers, basically had full, complete access to the phone. It could have done anything it wanted to. That one was believed to be downloaded between 50 and 200,000 people before it was caught by Google. Google has a built-in, as does Apple, built-in kill switch. So they can basically, anything you've downloaded from their marketplace, they can go, oh, that was malicious, we're going to pull that back off your phone. So they use that kill switch. They've used it one more time before on another researcher had out there a proof of concept called Rootstrap, which was basically the same kind of thing that they actually did maliciously with Droid Dream. So one of the other second times they've actually used their kill switch to pull the malicious apps back off the phone. What they then did was they have no official way to unroot a device. So they put out what was called the Android Security Update or something that you could download from the marketplace, which was basically unroot your phone. So, and they were nice enough to root your phone for you, but they didn't want you really having that. So they put that out there for you to download. Well, ironically, 3 days later, I believe, it was found on the Chinese App Store, the pirated App Store, the same exact application, except it was Trojan, which would then go back and reroute your phone and run all the malicious applications again. So, May 2011, a new stripped-down version of that Droid Dream Trojan is found in 26 applications, and I think between 20,000 and 120,000 people were affected by that. Because Google's not putting out official numbers, this is just people guessing at the numbers. In 2011, you see Plankton, which was another Angry Birds spyware app. Basically said it was helper program for Angry Birds, and would sit there in the background and download your private information. So, I mean, it sounds bad, but Android does have some security built into it. They specifically, every time you install an application, it tells you what things it's going to be able to have access to. So this app says, your personal information, your contact information, network communication, storage, almost everything. I don't think GPS, but it also starts up in the background, and starts to boot. So it puts the security into the user's lap, but a lot of users are not going to read this information. How many of you have Android devices? How many of you actually, when you install apps, look at this and make sure that everything is actually needed? Couple, exactly. Most people just say next, 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 install my app. So even though you have a TapSnake app that's clearly said when you installed it, this needs access to your network and to your GPS, which why would a TapSnake game need access to your GPS? It clearly said that. Most people just said okay and just let it go. So there are some, this is where they differentiate between Apple. Apple's not going to ask you these kind of things, but this puts it in the user's hands. So you have to pay attention to this. Don't install pirated apps to try to keep yourself covered. Only install apps that you know are the real thing. If you sideload apps, chances are it could very well be a pirated app. If you're going on to FileProp or whatever to find your applications, could be a pirated app. There's a good chance of that. So that's basically what the protection's built into Android. So as you see, it's a lot of open system, but with that openness comes a lot more risk. So take it for better or worse. So let's look at my predictions for the future of mobile malware. We're going to see an increase in the complexity of mobile malware. Just looking, it's going to mirror the PC side of things. We're going to see rootkits for the Android and other mobile operating systems. Basically what a rootkit does, right now the application will run in the background. If you look at the process list, you can clearly see it. You don't know why it's running, but it's still out there running. What a rootkit's going to do is that's going to start in the background. You're never going to see it. You're not going to know it's out there. It's just going to be out there running in the background. You're going to see polymorphic malware. So basically what polymorphic does is every time it propagates, it changes itself a little bit. So if we do see antivirus out on the mobile platform, it's now going to be changing itself so to try to get around that antivirus. We're going to see jailbroken iOS apps that are pirated and Trojan. You're going to see mobile malware used to steal data from corporate networks, because when you really look at it, just like modems can be used to get into a network, you can use your phone. I mean, there's people going into corporate networks. What does this have on it? A 3G modem and Wi-Fi card. That's the perfect way to bypass firewall protections, bypass DLP protections that may be out on the endpoint of the networks. So if you manage to install something on here that can, for instance, go onto the file share of some Fortune 500 company, now it can sit there and upload whatever access, whatever credentials you may have on this phone, have access to, trade secrets, that kind of stuff can now be sent off through the 3G network, and the corporations are going to see it flowing through their firewall. That's one of my predictions. You're going to see a lot more motivation in the future with near-field communication payments. I don't know if you've seen this or not. They're working on systems that's actually using it in, I believe, Japan and some other Asian countries, where you're going to use your cell phone to buy things. You just put your phone up to it and beep, it clicks, and it knows who you are and deducts it from your account, just like your debit card does today. With that, you're going to see a lot more motivation for people to write malware. Instead of stealing, $6, $10, and sending premium rate SMS messages, you could theoretically do thousands and thousands of dollars at a time. So, there's a few of my predictions for the future. So that's all I have really on it. Any questions out there? Yeah. Theoretically, yeah. If the malware gets on your phone, they have full control of your phone. So if you for instance, rooted devices, any of the devices have full access to your phone. So not only can they see where you are if you have GPS on your phone, they can take pictures, they can take video. It's all built into the operating system. So yeah, it's definitely possible. I haven't seen any out there. I'm sure there are official ones for Android out there, spyware apps out there. Any other questions? No? All right. Give away some door prizes real quick here.
So, did you enjoy that?